Okay, so today we're going to talk about section 8.6. Okay, and so first of all, if we look at that very first slide on the sheet of paper I gave you, it tells you these are sectors, these are not sectors. So based on what you see, either up here on the screen or on the sheet of paper I gave you, I want you in your groups to determine what is a sector. I want you to come up with a definition. I'm going to give you about a minute to a minute and a half. All right, this group over here, what'd you guys get for a sector? Okay, circle with 2 radius points. What'd you guys get for your definition?
Slice that touches the middle of the circle.
Slice that touches the middle of the circle. Okay, what'd you guys get?
A division touching the center of a circle.
Division touching the center of a circle. What'd you guys get here?
Part of the circle that's made with an inscribed angle.
A part of a circle that's made with a central angle. What about you guys?
2 radii receding from the center of the circle.
Oh, okay. Alrighty, not bad. Okay, so let's look at the next one. A segment of a circle. Okay, a segment of a circle. Once again, I want you to define. Okay, and we'll get back in about a minute. Okay, so let's start out with this group right here. You guys start first. What did you get a segment of a circle to be? A chord? What did you guys get?
An area defined by a chord.
Area defined by a chord. What did you guys get?
A chord separating parts of a circle.
A chord separating points of a circle.
The area enclosed by a chord.
The area enclosed by a chord.
Chord.
A chord. Okay. Alrighty, let's go ahead and look at the next one. An annulus. Okay, I'll let you guys go ahead and come up with your definitions. Okay, so group back there. An annulus, what'd you get?
What'd you get, Lane?
I got the region between 2 concentric circles.
The region between 2 concentric circles. Okay. What'd you guys get?
Circle within a circle.
A circle within a circle. Okay. Emma, Michaela, what'd you guys get? A circle inside a circle. What about here?
A disc inscribed in the circle.
A disc inscribed in a circle. What'd you guys get? An area created by concentric circles. Okay, so now what we're going to do is we're actually going to go over some formal definitions, and we'll see how close your definitions actually match up the ones that I have. And so you have a sheet. You can go ahead and fill these in. Okay, I left the space blank. But a sector of a circle. Okay, we got some of you that said a central angle, some of you that said 2 radii. It is a region. Okay, first of all, it's a region. It's an area between 2 radii and arc of the circle. It's a region between 2 radii and an arc of the circle. So the best way to think of a sector is to think of a piece of pizza, because that's what it is. Now, a segment of a circle. Once again, we had some of you that said it was a chord. A segment's actually a region as well. Okay, it's a region between a chord, so there you go, we did well with that, and an arc of the circle. Okay, it's a region between a chord and an arc of the circle. Notice there were some big segments, there were some little segments. All right, we'll see how well you have with an annulus. What do you think the first word's going to be?
Region.
Region. Okay, let's see. Yep. Region between 2 concentric circles. Region between 2 concentric circles. Now, if you remember, a concentric circle is similar to a bullseye. Those are circles that all have the same center. Okay. All right, so now what we're going to do is we're going to talk about how you find the area of each of these 3 things. Because we've already found the area of circles. Now we're going to find out how you can find the area of a sector, the area of a segment, and the area of an annulus. So the reason why I printed you off the note sheet is because it all has the areas there. So that's a great reference for you. So first of all, the area of a sector. We have a picture of the sector right here. Okay, we have R and A. A stands for the arc, R stands for the radius. Here is how you find the area of a sector. You are going to take the arc divided by 360 times pi r squared. So whatever that arc measures, divided by 360, where do we get the 360? It's the entire circle, right? So the arc divided by 360 times pi r squared. What about the pi r squared? Where did that come from? Area of a circle. So basically we're figuring out what fraction of the circle times the total area. Next we have the area of a segment, and that's on the back of your sheet that I gave you. Okay, now notice, look at our segment, all these different diagrams here. What we're doing is we're taking the area of the sector right here. So the area of the sector, okay, minus the area of this triangular region. And that gives you the area of the segment. Okay. And then the area of an annulus. Basically, you've got two circles, and I think you even had one of these on your homework, either on your worksheet. Yeah. And so what you're going to do here is just take the area of the big circle, which is right here, minus the area of the little circle. And that's going to give you then the region in between. So now the next thing we're going to do is look at an example of each of these, and then we'll be done for today and you'll be able to work. So let's go ahead and look at this. It says find the area of the shaded sector. So we need to identify which of the three, and it tells us it's a sector. So we're going to go to that formula. That formula states A divided by 360 times pi, let's undo that one, times pi r squared. So we have to figure out what we know. A is the central angle here, but A also refers to the arc. Remember, those two are equal, we learned that. So this arc is also 45. So I'm going to plug in 45 for A. And what am I going to plug in for R? 20. Okay, so what is 45 divided by 360?
0.125.
0.125, it's basically 1/8. Okay, times pi times 400. So let's look at that. 1/8 times pi times 400. 8 goes into 400 how many times? 50. So your answer is 50 pi. Label will be centimeters squared. Okay, now once again, you can use the pi button on your calculator. That's what I want you to use. I don't want you to use 3.14.
Show me the in terms of pi.
It'll tell you what it wants you to do. If it wants you to leave it in terms of pi, or go ahead and answer with the pi figured in. Okay, let's go and look at the next one. Oops, go back. Find the area of the shaded segment. So first of all, let's figure out what we know. Okay, for the area of the segment, we need to know A over 360 times pi r squared minus 1/2 B times H. So what is this distance right here? 90 degrees, because that parallels this measure. Okay, so far I know I've got 90 over 360 times pi times 6 squared. Okay. So now I've got to figure out some other things. So I need to figure out, for my next formula, this distance here, which is the base.
Well,
What's this vertical line here?
6.
6.
well, that would be
Okay.
18.
So how can I find this distance here? Pythagorean theorem. So somebody tell me what the Pythagorean theorem is?
6.
Yep, so
Plus 6 squared equals
6 squared plus 6 squared equals
square root of 72.
c squared. So I know 6 squared is 36 plus 36. What is 36 and 36? 72. How do I solve that now?
Take square root.
Square root. So what is the square root of 72? And I'm looking for 2 decimal places, please. 8.49. Somebody else get that?
Yep.
Okay, so that is this b. 8.49. Now what I need to find is the height, which will be this distance right here. Okay, so I got to find that perpendicular distance. Well, what do I know that this distance here is?
Half of 8.
Half of 8.49. So that distance there will be 4.245. So I got to do the Pythagorean theorem again. Okay, so we'll call that side the height side h. So h squared plus 4.245 squared equals what?
6.
6 squared. Okay, so what is 4.245 squared? 02. 6 squared is 36. So what do you do now? Subtract. So h squared equals 17.98.
Yep.
What do you do now? Square root of that. So what is the height?
4.24.
4.24 you said?
Yep.
Okay. Alrighty, so now I got to calculate that whole thing. So let's start. 90 divided by 360. I know that's 1/4. Okay, or I could do 0.25 times pi times 36. Okay, so what is 0.25 times pi times 36 as a decimal to the nearest hundredth? 28 point what?
27.
Okay, so I got 28.27. Now I've got to figure out this mess right here. So I've got 1/2 times 8.49 times 4.24. What is that going to be?
17.99.
Did you take it times
18.
1/2? What?
18.
18 even?
Yeah, because it
Well,
runs
oh,
up.
I know.
Okay.
17.998.
17.998. So now I need to take 28.27 minus 18, and my answer is 10.27. Label will be centimeters squared. I'll tell you right now, segments are the worst one of the three. They're going to take you the longest. Okay.
How did you get 28.22?
0.25 times pi times 36. All right, so let's go ahead and look at the last problem. This one's a little different. It says the shaded area is 14 pi centimeters squared, and the radius is 6 centimeters. We need to find x. Okay. So x also refers to this distance here. So the formula for the area of a sector, a over 360 times pi r squared. So we're just going to plug in what we know. Okay. We know that a is x, so we'll just call that x, right? And I know that my radius is what number?
6.
6. And I also know that the entire area is
14 pi.
14 pi. So first things first, I'm going to simplify a few things. Okay, I know that 6 squared is what? 36. Okay, so let's cancel some things out. 36 goes into 360 how many times? So really I have x times pi on the top, okay, divided by 10 on the bottom. So x times pi on the top divided by 10, and that equals 14 pi. What can you do with the pi buttons? Or pi, sorry, with the pi terms? I can cancel them because there's one on each side. So now how would I solve that for x? Multiply by 10. So what does x have to equal? 140. So 140 degrees. So I'm going to warn you. The segments are going to take you a little bit of time. Okay? You're looking at pages 455 through 456, 1 through 14. Please take your time. Please show your work. If you have questions, please ask. Okay?
Okay. You know.